open source electrical discharge machining, a library but for filaments, and a micro shredder for plastic recycling were just some of the things that I found at the Rocky Mountain RepRap Festival 2024. Join me on this trip and learn how you can machine metals with the power of sparks and always find the perfectly colored filament for your project. Let's find out more. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. This video was made possible by our own online shop cnckitchen.store, which is the best way to support our work. Get free worldwide shipping for orders over 100 euros. One of the things that we sell are our top quality heatset inserts, which transform every cheap looking plastic print into a professional part and which make them so much more useful. We have custom installation tips for more soldering irons to melt the inserts very easily into your parts. Check out our complete range of stainless steel Torx screws from M2 all the way to M5, so you never strip your hex keys anymore and throw away your chunky deburring tools because they're made for drain pipes but not for complex 3D prints. If you ever tried our slim blades, you never want to go back anymore, and they are also available for lefties. Support my work at cnckitchen.store and get high quality maker accessories. 2024 was the second year of the Rocky Mountain RepRap Festival, taking place in Loveland, Colorado, which is just an hour north of Denver. I flew in all the way from Germany because last year's event was already great. Yet this year they were able to get even double the space for the weekend, full of 3D printing, tinkering, making, and great conversations. Let's start with honestly my highlight of the whole show, even though it doesn't necessarily have anything to do with 3D printing. This is Robotics with their open source EDM or electrical discharge machining device, which allows you to cut any conductive material with the power of sparks. They set up the most amazing demo, which made me feel like a Jedi Knight cutting through metal with a lightsaber. I was lucky. This is a brass rod cutting through an aluminum sheet with a ton of tiny sparks, and I'm not sure if anyone has ever set up a similar hands-on experience for EDM. But let's give Cooper the opportunity to explain the process a little more.
This is electrical discharge machining, or EDM. It's a thermal machining process. So what we do is we use the PowerCore V2, that's our power supply here. It's going to be open source in just a few weeks. And we get two pieces of metal close together. So as we get the two pieces of metal together, we apply an electrical potential between them. And we have a dielectric, in this case distilled water, between those two pieces of metal. When they get close enough, there's a dielectric breakdown. It makes a little lightning bolt that goes in and vaporizes both pieces of material a little bit, the target material a little bit more. So in this way, we're able to machine any conductive material: aluminum, brass, steel, stainless, titanium, tungsten carbide. These are all things that we've tried so far. Hopefully I can get polycrystal and diamond nozzle. I want to try one of those. Yeah. It should be conductive. I'm going to go see if I can bother them.
I was wondering if there are metals that cannot be machined with the process?
Okay, that's a really good question. So one thing we've found prevents metals from being machined would be if there's a non-conductive coating on there, like type 2, type 3 anodize, or like if you have, someone brought over a plastic-coated piece of metal previously. We can't cut that. Like anodize, that's an aluminum oxide layer that's non-conductive enough to keep us from being able to cut. But if you're talking like practical ability to cut something that is electrically conductive, the thing that's going to be your limitation there is going to be the material thickness and material type. So different materials cut at different feed rates if you're talking consistent thickness between them. So like if aluminum's cutting at 10 millimeters per minute, your steel is going to cut 4.5 times slower than that. So that's because of melting point or boiling point of the metal and the density of it. So titanium, it's not very dense, but it has a pretty high boiling point. That cuts around 2.5 times slower than aluminum would.
Okay.
So you've got, those are just rule of thumb, but your actual implementation is going to change slightly. That would be the major things. So it would be like if there's a non-conductive coating or if it's super like thick or hard to machine.
Robotics successfully kickstarted their EDM system last year, initially using just a simple rod electrode to cut through metal. Ever since then, they added new tools. Let's first take a look at how the wire tool works. Wire EDM uses a very thin wire as an electrode to cut the metal. And since not only the workpiece but also the wire itself gets slowly eroded away, new wire gets constantly fed into the cut. Let's take a look at how the wire tool works.
I can take off these magnetic quick disconnect panels and show you a bit more under the hood. These are here for safety and aesthetics, and they're what you would print yourself, so you could make your own colors if you wanted. So the wire comes off of the spool holder up here and goes down into this Bowden tube. It'll then pass down through the tensioner system in the tube and go into this pinch roller here. So we have a long lever, mechanically advantaged, to pinch that wire. You need quite a good deal of force to get resistance to pulling on that. So it goes through that pinch roller, and then it goes through a ceramic wire guide that you can't see inside of this 3D print. That provides XY location of the wire's axis in relation to the tool. From there we go down to the first idler. That just changes the direction. It goes over to this tungsten carbide block, which is what brings it into the circuit. It connects it to your EDM pulse generator. It goes right up this idler and then back to a waste spool at the back. That goes onto the Wago bus. We've got grounding for the aluminum endoskeleton, which in production is going to be type 3 anodized. And then we also have spots for the unused anode wires here. So you've got your long twisted pairs going all the way here, terminating as close to the spark gap as possible. We're doing that to minimize EMI. But yeah, so this goes together really similarly to an FDM toolhead.
Of course, you need to hold your part during the machining process somehow, and on a mill, you'd use a sturdy vise. Yet in EDM, you can get away with just flimsy 3D prints, and there is a reason for that.
You're going to need to 3D print some tool holding. So you can see right here, I've 3D printed the tool holding for the demo. This is just some carbon fiber PLA. The forces in EDM are so low that you can get away with 3D printed tool holding, which is really nice, because you can get a custom tool holding for any specific job. So you can get custom work holding for any specific job you're doing, whether or not you need different, like multiple different pieces of work holding for it, or you want to parallel that out and have several of them. Super easy to get that set up. So you'll 3D print these, and then for the current vat design, they slide into a slot here, and then just get bolted down into location on the inside of this. So this vat's 3D printed, and I coated the inside with epoxy to make it waterproof. We could also potentially print it out of something like ASA and acetone smooth it to make it watertight.
This sounds all super interesting, but what are the actual uses for such a setup?
Okay, so the uses for this would be something like send cut send at home. You want a laser cutter service provider at home. I don't want to wait 5 days to get my laser cut parts. I'd rather have them in 2 hours. So that is the primary use of wire EDM at the moment.
Cooper's colleague John had something else to add.
High aspect ratio cuts too. So if you want to do something that's tall but with a thin feature, that's something you use EDM for. I think EDM is also excellent for making gears. If you want to make a gear on like a CNC machine, you need a lot of custom tooling. Versus if it's an EDM machine or a laser, you know, it's just a path. This has an advantage over a laser though. It doesn't produce like a curve, so or a taper. So fiber lasers, for instance, through like 10, 12 millimeter aluminum, we really start to have to worry about taper. If you're working on a plasma cutter, you have to worry about dross and you'll get like burnt parts out. This doesn't have that problem. You can make high aspect ratio cuts with straight walls. It's also great at making sharp internal features. A regular CNC machine, because of that end mill, you're gonna have like a 1/4, 1/2 inch, 1/8 inch internal diameter minimum. But with an EDM machine, you can go down to like 150 microns on this. So we can make a 150 micron internal corner.
Yet why did they even start building a DIY EDM power supply and machine?
A couple years ago, like probably 5 years ago, John and I both independently started doing research on the machining process of electrochemical machining, which is another low force, non-contact process. But instead of using like water dielectric, that uses a salt water, and it's more current based. So you'll have super low voltage, and you're doing a redox reaction to electrolyze the target material. That process we both worked on for a long time, shared notes, for kind of secretly we're hating each other, like I'm gonna have the better UCM setup. And I actually built an ECM conversion for the Ender 3 previously, and I threw that off open source, and it wasn't very useful. I was able to cut thicker materials, but due to the ECM process, you don't get machining accuracy. Like, even if you're able to get your electrodes really close to each other, you can't get that to be accurate or not tapered. So John and I actually found ourselves working together at a 3D printing startup. And when that startup like just almost went under, we both got the boot, and we were stuck in some place where we had moved to for the job. And we're like, okay, let's make something. And we were already just he and I talking about EDM before that, like ECM is pretty terrible, like it's not good. How hard could it be to make an EDM, pulse generator? And so we actually found out that one of our friends in Germany, Dominic Meffert, he had been doing electrochemical machining with us, and he had made an EDM power supply out of literal ender parts. Like for a power resistor, he used the hot end resistors. So we looked at what Dominic did, we took some inspiration from that, and we made some pretty serious changes and made it something we could produce. And after experimenting with that for a bit, we realized like, you can use this. This is actually useful. So that's how we got started with it. And that was back before the Kickstarter.
What's the difference between a regular power supply and an EDM power supply?
A constant voltage power supply, let's say, right? So that'll supply as much current as it possibly can at any given time. The power core supplies extremely high current, short sparks. So we're running 5 kilohertz sparks right now, can go up to 20 kilohertz if you modify the firmware, which you'll be able to. So we need extremely high power, short sparks, and they need to be going fast.
What kind of voltages is the power core using to create the sparks for EDM machining?
EDM machining, by its nature, benefits from being a high voltage process. So when you have that dielectric breakdown, you want to reach out a little bit further than something like 36 volts could do for breaking that down. So we're running this, it's currently 65 volts at the output cap, can go up to 72. And in the future, we may actually raise that up again over 100, 110, because we want to increase that spark gap so we can get more water flushing through the gap. So the longer your spark gap, you get a much easier time flushing that gap, and you're going to be able to cut faster, and you're not going to have as many shorts or problems with like waste getting stuck between the electrodes.
Yet how does their power supply compare with a commercial EDM power supply or setup?
To be totally honest, the capabilities are lower. It's not as powerful of a supply. It's not as fast to machine with, but it is the machine that you have and that you can actually get. You don't have to spend $150,000 on it. It can do plunge EDM. I've done plunge EDM recently with this on Air 500 steel and titanium. And I've also made a little tap burner that is compatible with this. I'm going to be releasing that pretty soon, open source. Just a little single axis burner. So this is capable of plunge EDM and it's capable of wire EDM. So like peak power is your limitation.
So whereas in wire EDM, you cut apart by running a wire through it, in plunge EDM, well, you plunge a negative of your desired shape into a part. This is a very popular process in tool making for injection molding, where you need precise and very detailed cavities in very tough steel, which would be hard and often impossible to do with conventional machining. Yet in EDM, you always need to make sure that you have this small spark gap where the sparks form and which is kept free of debris by constantly flushing it with deionized water. Running your EDM tool too fast will make it touch the part, causing a short circuit, which will then not produce any sparks anymore. And you probably break it. So you either run the tool very slowly, which is inefficient, or you get a feedback when a short happens. So you can retract a little to clear the gap and form a spark gap again. I was wondering how they handle this.
So the power core has 2 data outputs, but we have a current sense output, which is an analog signal, and then we have a short alert output, which is just a digital signal. So if you crash your electrode, the digital output will say, hey, you crashed. And that's what I'm using on the little tap burner. It's basically just a little single axis Arduino. That was the easiest way to make a closed loop. When you're running something like Marlin, there are some forks out there for closed loop controls, but I haven't had success with them. Clipper, we're actually looking at a path where we think we can make that work closed loop. And then there's some people out there who have made wire EDM machines with the power core using Gerbil closed loop, and that's very reliable from my understanding.
Clipper is the perfect segue to their new 4-axis EDM machine, which is called the Beta Wire, really running on Clipper and which lives in a shark tank.
Yes, so the entire machine fits inside a standard 10-gallon aquarium from Walmart. The main constraint for this was use off-the-shelf components so it's easily replicatable, and then to use like a 10-gallon aquarium, which is the most difficult part of the machine to actually fabricate if you're just using a 3D printer. So this makes it easily replicatable, easily revisable, and low cost. It's basically 2 core XY systems stacked on top of each other. There's a bottom gantry here, core XY, top gantry here, core XY. You can see all the belt pathing, A path, B path, C path, D path. All of the motors are contained in this top compartment above the water line, so there's no need to waterproof all the motors. It's driven by a Manta M5P running clipper. So as far as I know, this is the only wire EDM machine in the world that you can control from your phone. You can run this from like your desktop computer from across the room, hook up a USB camera, you can watch it remotely. The wire comes in through this blue tube, gets sent through the machine. There's a Bowden tube here, goes to the bottom tool head, and the wire gets sent up, and that's where it does the cutting. So right now we have 2-inch thick aluminum here that we've been cutting, and then it gets wrapped up on this spool. So there's a 24-volt motor in here, wraps up the wire. That's what holds the wire taut and allows us to cut. So this machine has a travel of 120 millimeters in the Y and 250 millimeters in the X. So it's relatively spacious. We have a vise in here for holding our work. And that's the surface finish, it sparkles.
And even though this looks rough on first sight, the surface finish was really smooth, and EDM also allows adjusting the surface roughness by your machining parameters. You might have noticed that John said that they were using 2 Core XY systems, which allows you to move the upper and lower tool head independently. So you can even cut at an angle.
Yes, so you can use this to make chamfers, you can use this to cut tapers, you can cut angles. So if you have a component you want to funnel like a liquid in through, for example, like an extrusion die, that's something you can do on this. 4-axis wire EDM is an input for most of like plastic and metal extrusion. If you're making injection molds, you're probably using wire EDM. If you're building dies, for example, if you're crimping dies, that's also going to be wire EDM. And previously, that sort of technology was completely like outside the scope of what the typical person had access to, or like the typical university student, or even the typical engineer. There aren't that many wire EDM machines in the world, and they cost sometimes as much as a house, and they're about as big. They'll use kilowatts of electricity. They have expensive consumables, but because this machine is affordable and it's compact and it's power efficient, it's the sort of thing that an engineer could have in their shop or their garage. It's the sort of thing that a university student can have access to build whatever they can imagine.
And since this machine is all off-the-shelf components, it's, compared to commercial solutions, really affordable.
The price for this build is about $1,200. It's mostly 3D printed. We're probably going to be starting this off as like a self-source kit, and then we'll do a full source kit.
I wanted to know how you create G-code for EDM machining.
So G-code is very simple for doing 2D cuts. You can use like laser cutting software to make G-code. We're also going to be releasing in the near future a like CAD CAM suite. So we're working on that. And when you want to do 4-axis cuts, it'll probably be in the form of 2 SVGs or 2 GXFs. It's like a top path and a bottom path, and the angles will be calculated.
So EDM machining is comparably slow to milling, for example. Yet the huge benefit of EDM machining is that you don't need any forces to move your tool, which is here the wire through your part. So I wondered what kind of precision we could expect on their current wire EDM.
The tolerances are really going to be downstream of whatever kinematic system you're running on. So if you're using EDM wire guides and you have like a good tuned system, it's really just a function of like how accurately your motors can turn and like how rigid your frame is. You can get down to tens of microns, maybe single-digit microns in a well-tuned machine. Something like this will be about as accurate as like a typical 3D printer. It's a very low-force process, which means that you aren't fighting, like your machine is not fighting anything. If you have a CNC machine, it's constantly fighting the force of the metal pushing back. But with the EDM machine, because it's low pressure, relatively low pressure water and just wire, you don't need a lot of rigid components in this. So this just uses 3D printed plastic and steel rods.
I'm honestly hooked on this and don't only want to feel like a Jedi again as soon as possible, but would also love to have a simple and inexpensive wire EDM tool to cut open parts that I want to inspect, or even have the possibility to work with really hard to machine materials, or maybe even make custom nozzles. This is still a niche market, but due to being open source and accessible, there will be a ton of applications for tinkering, research, and also production we can't even think of at the moment. What would you like to use an EDM for? Leave a comment below. If you have ever wondered how to find the perfectly colored filament for your model you want to print, or look at a combination of filaments that go together really well, then you need to check out filamentcolors.xyz. I met Joe at the show and had a great chat about what they do, how they do it, and how you can benefit from it. So what's filamentcolors.xyz?
The short version is that we get filaments from all over the world. We print them, then we photograph them on here, and then we color match them.
So Joe prints all of these filament swatches. Coincidentally, these are exactly the same ones that Stan also used in the last video for his tests, where he left 3D prints outside for 7 years. They have 4 different thickness steps to also get an idea of how thinner prints will look. So where do they end up then?
Then we stick them on this website. So what we do is we have over 2,000 colors that are currently on the website. I'm going to go ahead and pick this one because it's handy. So we give you a nice full-size image of what it looks like printed, instructions on how to print it, where you can buy it from, then Pantone and RAL color matching if you're into that kind of thing. Then we auto-generate color palettes based on this as your root color. So let's say you've printed this and you're like, I love this color, I want more things that look good with this color. Then here are suggestions on what to buy from different manufacturers across different filament types of things that will look good with this. We also give you the things that are closest to it. So let's say you've got this as your primary color and you've run out and you can't buy any more. Here are 2 others that you can try to buy that will help you finish and get to the end.
So this is amazing. With this website, you're able to find alternatives for your filament if you can't currently get it. Or if you have one material that you love printing with and want to use it in a multicolor project, you can easily find different filaments that go very well with that color. Yet in my opinion, the best feature is color matching. So you can input a color via RGB values, for example, and the app will find the best matching filament to your input. This is basically the unique thing about filamentcolors.xyz.
Here we also have this ability to color match. So let's pick a color that's a little easier to see. So this one. So you can search based on all of the colors that we currently have available in the library, and you can build your own color bags, really. So let's do this one, and then let's do a nice, that's not a nice, let's do a nice green. Okay, and we'll pick this one. So you can create your own color system for your project. Now you have a link that you can hold on to them, just the colors for your specific project.
If you go to an online store and look for a color, you never know how they will really turn out when printed, because the images of the spools are always made with different settings. Joe gets rid of this guesswork because he always prints the same samples and photographs them in a repeatable way. So you can really compare colors and even find the ones that you really need. There's not always a perfect match, so how can you tell how close or how accurate the color is that you input compared to the filament on display?
Also, since you're looking for something that's hyper specific, I'm going to show you a secret. If you go up here to the settings bar and then click show advanced, you can toggle show delta E distances, and this will actually show you the raw numbers underneath that calculation. I got to scroll all the way down to the bottom now because it's advanced. So let's go back to that orange, or at least try. Yeah, it's close enough. Then that shows you the numbers under here. And so 5 and below is really good. 10 and below is like, it's close enough, you probably won't bother. The gray number right here. So if you're doing a really advanced specific color matching, then that's the thing you want to toggle on. The only reason that it's not on all of the time is that it runs all of the math twice, and it does have a noticeable speed impact on the site.
Another trick that is really handy is that you can select and deselect different manufacturers that might not be available in your region. Yet how much does this app cost to use?
And it's totally free. There's no ads, there's no user accounts, there's no tracking, there's no nothing. This is old school web because I like it that way.
Yet, how do they finance the project?
So the way that we're financing this is essentially out of pocket. This is a hobby for me. This is not a business. And what we do is we have affiliate links on the website. So if you have a filament on here that is an Amazon link, it is always an affiliate link. And if you find a filament that has an affiliate link with the manufacturer, that will be noted on the button. So I have affiliate link agreements with about 1/3 of our manufacturers now. It's a growing number, but a lot of the big ones. Yeah. So that's what pays for the site. The site does pay for itself. And then we take individual donations as a way to bolster our equipment budget and our filament budget. We try to get new filaments every month. And right now we get between 4 and 8 new filaments every month at the very least, that are ones from my budget, not counting the ones that come in as bulk donations.
Even if you can't support the project with money, you can send in samples of some of your filaments so that they can add them to their library.
If you have filament that I don't, then I only need about this much. I need a little bit more than this. So just a couple of coils that I can print our little tiny swatch on, and then I can photograph it and do all of the normal things.
So let's take a closer look at the device that they built to take the pictures of the swatches.
This, for example, is a completely custom piece of equipment that we built specifically to always take the same pictures. So we have this ability right here to, there we go. So we can always put the swatch in the same place in the center every time. And then we blast it with 192 LEDs and we get a beautiful picture that we can put on the site. So this is what we use to take all of the pictures that end up on the site. So it looks the same every time and we get nice, good quality out of it.
How do they make sure that they have good color accuracy over time?
I have a card that is all of like major colors for like photography testing that happens to be the perfect size to fill up the entire frame. Okay. So I use that as a testing bed, and then I set white balance to that. And then since I have the same card, then I can retest as necessary. But the white balance itself is actually hard-coded into the device, so it doesn't try and recalculate white balance every time I take a picture.
In the last video, we have seen the beautiful 3D printed images that you can make with UForge. But for UForge, not only the color of a filament is important, but also the TD value. So how opaque a filament is. Wouldn't it make sense to include these TD values also in Joe's filament library?
We've actually talked to Steve at UForge a couple of times now. We're hoping to make an integration so that we can pull data from the site and do kind of a community managed version of the transmission data, the transmission values that UForge needs. I just recently got myself a TD1 so that I can start measuring that data myself. And we're working on a system that is separate from that so that I can measure the TD value on swatches that I have already printed. This is still very much in flux. We're working on the design of it and not 100% sure if it can work, but I think it can. Fingers crossed. But yeah, I'm really excited to work with UForge and get that data to those people.
That's really cool and would add value for everyone who uses UForge. I have another use case. I, for example, love Prusa's orange filament and try to find alternatives that are easier to source. However, all of the ones that I got so far were a bit translucent and didn't match the appearance of Prusa's orange filament. I would hope that the transmission distance value would give me the possibility to compare this property as well before purchasing. So I experienced in the past that I bought 2 rolls of filament and one wasn't manufactured in the same batch and the colors didn't match. Since Joe already has tested so many swatches, I was wondering what his experience was and how they handled it.
So it doesn't happen anywhere near as much as it used to. From about 2016 to 2019, this was a really big problem, and now it's mostly gone away. So we do have a system for dealing with that. If we get a newer version of a filament in, then I reprint the swatch and I measure it, and then I update the values that are on the site so that you're always looking at the newest version. If there is a major change, a major departure, then I will make a V1 and a V2, and I'll keep the old version, but generally speaking, it's not anywhere near as big of a problem as it once was.
As a last question, I wanted to know what Joe would like to still improve on his device.
Honestly, I love this machine. I have gotten it to the point where it is absolutely perfect for what I need. I would love to automate the base of it so that I could just load in swatches in like a carriage and just have it just go through them. I think that would be so cool. So that's an idea. I also want to fully enclose it and make it so that like something I struggle with is cat hair. I have 3 cats. I love my cats, but getting cat hair out of the images means I occasionally have to reshoot those pictures. So I want to add like a fan and keep a steady flow of air going over it to get rid of hair. Those are upgrades that I have planned, and I'm really hoping that by the next time you see this next year, I'll have at least some of those built in.
So this was an in-depth look at the filament library, which you should definitely check out if you're looking for the right color material for your project. And if you can, consider supporting them because they can help you to save a ton of money on wrong filament and get to your results faster. Have you ever made a bad experience when ordering a filament and it wasn't the color that you expected? Leave a comment down below. Last but not least, I talked to Bill from Recreator 3D, which I'm sure you know from their PET bottle to filament machines. Their process only uses the middle section of a bottle to make filament and can't work with the thick threads as well as the bottom of a bottle. Since they want to recycle the complete container and commercial shredders are quite expensive to get, they are currently working on a micro shredder that might not only be able to shred PET bottle leftovers, but might also be an inexpensive solution to do small scale print leftover shredding. But let's listen to what Bill has to say about it.
I'm Bill, I'm with the Recreator 3D project here in Loveland, Colorado. Yeah, we're here showing off the Mark 6 extruder or pultruder and also the micro shredder. We nicknamed the chop suey micro. So what it is it uses a simple router bit from Amazon and uses a stainless steel ruler as a cutting face. and you hook it up to a power drill. You put all your the bamboo poops in there, or your bottle tops. Anything that fits in here can be shredded down. Hook it up to your power drill, push down on the plunger, and it shreds it up. After 2 or 3 runs, you'll get nice little grinds like that you can use for injection molding or your ArtMe extruder or anything you can think of. The whole thing can be built for under 25 bucks. All the parts can be sourced on Amazon.
The Chop Suey Slim Shredder will not be a solution if you want to efficiently shred a ton of big chunks of your failed prints. But if you want to try out filament extrusion and have, for example, bamboo perch poop lying around, this might allow you to grind everything up into suitable sized bits so you can feed them into the extruder screw. The working principle is really simple. With a router bit and the protective stainless steel ruler that together shear and cut the plastic. If you want to take a look at it yourself, there's a link down in the description. Would you like to see an inexpensive but also safe shredder for recycling? Leave a comment down below. So this was the second part of the Rocky Mountain RepRap Festival coverage. If you are only the slightest bit interested in tinkering and making, make sure to visit one of these events at some point, because it's a really inspiring experience. So if you live on the US West Coast, then check out Open Source, a maker and YouTuber event that's happening mid-June at the Cow Palace near San Francisco Airport, with hundreds of exhibits and over 150 of your favorite YouTube creators, including myself, being there. Tickets are still available at opensource.com. Thanks for watching, everyone. I hope you found this video interesting. If you want to support my work, head over to Patreon or become a YouTube member. Also, check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye.